Welcome, everyone. Hey.
Or maybe we should start on time and do what we say we'll do. So we do have a lot to go over. And when I get excited, I talk fast. So I'm going to try to balance between talking quickly and not going too slow so we can get through things. Again, welcome all Druiders. Welcome, everybody. This is Tales from Support. Hopefully, we don't have any technical issues. I'm getting messages saying my internet connection is unstable. So let me know if anything sounds choppy. But we're going to talk about some of the most common questions, mistakes, and anti-patterns that we see supporting Druid. And to get started, we'll say a little bit about ourselves, if we can. So, as I said, the first thing that we can share is who we are. So, if we can go to the next slide, I'm Ben, and I'm a technical support engineer at Imply.
Hey, everyone. I'm Bala Tyagarajan. I'm Technical Support Engineering Manager at Imply.
And I have my Imply sweatshirt on. So I am, as I said, a support engineer. I have a good number of years in support. Before I worked at Imply, I worked at DataStax, supporting their distributed Cassandra offerings. Before that, I started out in support working for MySQL when they were still MySQL. When they got bought by Sun, I worked for Sun. When they got bought by Oracle, I worked for Oracle. Before I was in support, I was a DBA for quite a while with relational databases all over the place. And before that, a developer with, again, relational, also some other things like MUMS, which is a hierarchical database. These days, and I wanted to share this for after the talk as well, I try to hang out at druidforum.org, which is a great place to get your Druid questions answered. Same kind of questions that we might help with in support often. I try to watch the Google Druid user mailing list. And also I try to check the Apache Slack channel, hashtag Druid, as much as I can. So I encourage everybody to check all of those out after this talk and use them going forward to get help. Especially druidforum.org is a new and good place to go.
Thanks, Ben. Yeah, as I mentioned earlier, I'm the Technical Support Engineering Manager at Imply, supporting customers on Imply Druid Data Platform. I'm based in Bay Area, California. I've been doing customer support all through my career, and I love it. Before Imply, I was with Cloudera, Wipro Technologies, and IBM India. I've been in the data analytics space for more than 5 years now. And when I was in Cloudera, I primarily worked on supporting Apache Hive and Hortonworks data platform. Before that, an application support engineer and a system administrator. Okay. So next, let's see what Imply support team does. Imply support team solves issues and answers questions that arise using Druid and the Imply data platform. We do break fix. Support functions are ongoing and typically work off of a contract. We support Imply Druid Cluster, Imply Pivot, a data visualization tool, Imply Clarity, a monitoring tool for Imply Data Platform, and Imply Manager is a browser-based interface for deploying and administering an Imply cluster. Support team focuses on issue resolution and answering how to question, primarily in response to customer questions on that come in as support tickets. The mission of support is to be there for customer when they need help, and sometimes engage customers proactively to assure that they can use and apply their applications. It's not always about trying to fix something broken. Sometimes it's about starting over and create something better. In our troubleshooting process, we identify opportunities to improve our product and provide feedback to the product and engineering team, like feature enhancement request, and we collaborate a lot with the cross-functional teams. That's specific things about employee support. And then next, Ben will talk about whom are we supporting, who are our customers, and what we have done so far. Over to Ben.
Thank you. Yeah, our customers are all over the place across many industries. leaders in financial services, communications, as it says here, media, hospitality, retail, gaming, technology are common areas that we have customers in for the specific use cases that Druid is good for. But we have customers of all kinds and all around the world, in the Americas, in EMEA, in APAC, some in Israel, some in Europe, just all over. And we have 24/7 support. We have many customers, but some of the main ones that we can mention, because they've agreed to share their names, and you'll see them on our website as well. Some of the big ones are, as you see, Walmart, Apple, AT&T, Swisscom, Reddit, DBS, Cisco, Instacart, Expedia, Verizon, Twitter, many more, and large, medium, small. Since support inception, we've handled over 7,000 support tickets. We use Zendesk, so over 7,000 Zendesk tickets, and this year so far, over 2,000. So things are growing and ramping up, and we see a wide range of customers from a wide range of geographical areas with a wide range of issues. And so we tried to break that down for this talk, and we're going to get into that a little bit and then get into the main areas. But first, talk a little bit about how they get broken down, and Bala's going to show you a visual treat that we got from Zendesk Analytics.
Yeah, thanks, Ben. This is the breakdown of issues by type. It may be hard to read, sorry about that. But the three biggest categories on the right are configuration Druid, the one in the orange, and other Druid, blue, and the other that's in pink. The configuration Druid is a bit general and overlaps with several of the sections in our talk today. The next biggest category is very specific and ingestion Kafka, that's in the green, which we will also talk about a lot. In all, we get a lot of questions about a lot of things, and going over the statistics we have, we want to talk about what are some of the most common things we see in support, and then where our customer. I'll let it to Ben to describe that. Thanks, Ben.
Thank you. We got kind of a top 7, not quite a top 10, but again, I'm kind of talking quickly because we have a lot of meat in these top 7 to talk about. And you can see the top 7 here. I won't necessarily read them all out because each one is going to be a section of our talk. And so you'll see them as we go. And so with that, these are the most common kinds of questions, mistakes, and anti-patterns that we see. One of the biggest ones is that something is down or unresponsive, a node, a service, a lot of things. So let's look at some of the possibilities. We have, for this slide is the slide for this section. So it's a very concise slide, but there's a lot to say about each part. And so I'm going to go over that. And again, if I talk too quickly, I'm sorry. In run-throughs, I took a long time on this slide, so I'm going to try to keep it manageable. So the first most common thing is that the nodes for the cluster are under-provisioned. For example, if you have undersized AWS instances, you may notice problems right away, or you may notice problems as your load increases over time or your data increases over time. The biggest thing that we see, though, especially right off the bat, is RAM, not enough RAM. So if there's not enough RAM, Druid makes use of memory mapped files, direct memory. Sometimes there are other processes running on the server. Some kinds of servers have multiple JVMs. If it's, for example, running a lot of peons and they're all spawning up JVMs, this can cause your OOM killer to kick in, and the services suddenly die, and there's nothing in the log saying why they died. So you might look at it, or we might look at it and say, why did it die? And the log looks fine, and boom, then there's nothing. In this case, it's a pretty quick conclusion to check the system logs, dmessage, syslog, something like that. See if you see anything about the OOM killer. That's a common cause of that behavior. But another thing, if the RAM is insufficient, is that your heaps may be sized too small to fit into your RAM. In this case, you are likely to get a lot of long and frequent GCs, sometimes maybe even stop the world GCs, and the service becomes unresponsive. You may see high CPU on your node, making you think that you need to increase the CPU, but it may actually be RAM and your small heap size. So a lot of the Druid services can use a very small heap, like an Overlord service doesn't need much heap, but some of them need to be a little larger, and small is good, but not too small. So too small of a heap is a common cause of issues making things unresponsive. I'll do a very quick aside for my personal crusade. We don't often see larger heap sizes, but sometimes we do. If anybody is using, if we were in person, I'd say raise hands. If anyone using 32 gigabyte heap, then I'm going to say don't use a 32 gigabyte heap. I don't know if everybody is aware of this already, but because of JVM internals, if you have like a 31 gig heap and you say it's too small, I'm going to increase it to 32, 35, you may not be doing yourself a favor. Anything between about 32 and 45 should usually be avoided, because you kick on into 64-bit pointers instead of 32-bit pointers and get fewer address spaces until you get a bigger heap. So stay just under 32, or if you really need to for some reason, go up to 45, which usually doesn't happen with Druid. But to move on to our subject, the next common thing is that the disk space allocated is too small. In this case, logs can fill up the disk. Things will hang up. Nothing is logged to tell you what's going on. Maybe you just have to think to do a df minus k, find out that you need more disk space. So under provision nodes are probably the most common reason we initially see unresponsive endpoints. Another one is the metadata DB becomes unreachable or unresponsive. This can happen for any of the reasons that a database might become unresponsive. For example, network issues, which could cause issues anywhere in the stack here, but in particular for this case, maybe are giving you issues connecting to the metadata database. Sometimes it's that a password was changed for some reason. It could be anything, but something that's more specific to Druid is that customers who have thousands of data sources, for example, or hundreds of thousands of segments, and each one may have hundreds of fields, the metadata can grow very large in the metadata tables. And then queries against the metadata database become slow, and that can cause everything to slow down. If you do have one of these situations, maybe you really need, for some reason, thousands of data sources, or maybe you have a high churn of data sources. You're kind of testing and you create and drop data sources a lot. Same with segments. We recently added some settings to Druid. It's also an open source Druid that can help you automatically clean up older metadata entries for things like task histories, the kinds of entries that will cause issues leading to an unresponsive database. So if you're seeing this, I encourage you to look through the docs for a metadata cleanup, and you'll find some settings that you can use. And a very common cause for unresponsiveness is zookeeper issues that we see. Again, having a lot of segments can lead to this. If you have thousands of segments with lots of columns, the zookeeper may get stressed just trying to manage all these segments and spread the information about them. In one case recently, we had to increase some buffer sizes on the zookeeper and the historical nodes to allow the payloads to go back and forth between zookeeper and the historicals. Better to try to manage the data. And there is a setting that, again, it's not on the slide if you want to ask about it, Q&A or in the Slack or Druid form. It's a load QP on type. And we found that setting it to HTTP reduces the load on Zookeeper a lot and often can help performance overall. It tells the coordinator to get a lot of its information from other nodes instead of going to Zookeeper for all of its information. So this is a very quick overview, but these are common areas that we see problems and things to look out for of what kinds of things might cause problems. And to add to these, if you have these problems and say you're on AWS or someplace and you have health checks against your services, they might get triggered and then they start restarting your services and it compounds the problem. And now you're saying, why are my services crashing and restarting? And you have to kind of step back to find the cause that things were becoming unresponsive that caused the health checks to crash them and restart them. So overall, as general kind of common sense advice, the best approach is to be sure to test, do load testing, monitor. We have a monitoring tool called Clarity, and there are, of course, others. We'll talk more in the performance section, but just, monitor your system. When services or nodes do become unresponsive or crash, or if they do, check all the usual suspects, all the possible avenues. There's a lot of logs in Druid to check for each of your services. There's Zookeeper logs. There's operating system logs, and maybe CloudWatch logs. Distributed systems, are complex. So you want to check all the pieces and look for clues in all the different pieces and find something that looks like it's the ultimate cause of your issues. And once you're doing that and your nodes and services are up and running and they're staying up and running, the next most common thing that we run into issues for is something that Druid is very strong at, which is ingestion, but it's also a complex area that people can stress very hard. And so we run into areas of issues, and that is our next subject.
Thanks, Ben. So the next topic is ingestion. Ingestion takes a fair share of overall support issues that we get. This is a huge topic, but here we try to narrow it down to two main issues that we often see. The two main issues are like, why are my ingestion tasks are failing? And why are my ingestion tasks are very slow? So let's talk about the failures first. Disclaimer, this is the biggest topic of the whole presentation, so stay with me. Why are my ingestion tasks are failing? So we often get support tickets mentioning task succeeds, but we see offset out of range exception in the task logs. Offset out of range exception can occur due to many reasons. For example, there would have been some downtime or resource constraints or performance issues on the Druid cluster where the ingestion is slow or had to wait for a few hours before it kicks off. During this time, the events on the Kafka topic can get deleted from the topic due to Kafka retention rules. Once the cluster returns to normal state, the ingestion resumes, and we could see the Kafka ingestion task get succeeded without ingesting any data and creating 0 segments, basically. This is because Druid is unable to fetch the offset it is looking for from the Kafka. The messages are thrown are one messages, so hence the job is considered to be successful, and that's why you see jobs are getting succeeded, but you see no data in the end. In this scenario, we can try resetting the supervisor. It either reads from the oldest or latest offset based on the settings that we give in the ingestion spec. Use earliest offset property. If this is, but there are a few things to note before setting this up. If this is set to true, the Druid will try to pull the oldest offset available in the Kafka stream. Sometimes it may lead to duplicate data. So on the other hand, if it's set to false, then the Druid will pull the latest offset available in the Kafka streams. There is also a chance that data might get lost. So a strategy should be in place to take care of these scenarios. We could also increase the data retention time in the Kafka stream so that the events in the top topics stay longer time and avoid deletion. In some cases, we have seen customers having conflicting values set in ingestion spec. For example, late message rejection period. We have seen customers set it to 1 hour, and also they have used earliest offset true. This would reject messages with a timestamp earlier than an hour before the task gets created. The task could still succeed, but it would ingest only partial data. In this case, we should set a late message rejection period to a reasonable time frame that could minimize the chances of data loss. Second thing is issues on metadata DB. I think Ben has covered a bit on this. When the metadata DB is unresponsive for whatever reason, the ingestion task would fail or get queued up in the waiting state. In one instance, we had a customer with a higher load on a cluster where the RDS instance was actually bottlenecked and writing data to the disk. The number of concurrent task ingestion tasks was very high for the size of cluster, and that was leading to the ingestion failures. We recommend in such scenarios we recommend increasing the EBS volume if they are on AWS, because that would improve the IOPS throughput, write throughput, or resize the instance type. But this is an expensive, more expensive, but one can consider the option for a longer run. Next is task lock, or an overlap of ingestions. Ingestion task updating the same time chunk or interval. This can cause ingestions to fail. Task should get a lock before reading or writing a segment. Task lock is for coordinating all the accesses to a particular time chunk. For example, if the task needs to read a segment of a time chunk of X period, it should get a lock that time frame before reading those segments. While this task is valid, no other task can read or write any write for that particular time chunk. Sometimes the ingestion data size increases, and that can increase the task runtime in turn, and it may overlap with the next ingestion task that is writing to the same time chunk. In this case, tasks do not release their lock until they are finished publishing the segments onto the historicals. So having a shorter interval between ingestion task, writing to this ingestion task, like especially writing to the same time chunk, may end up overlapping. So when ingestion tasks are submitted programmatically, it is better to space them with a reasonable intervals. Next is historicals not loading the segments can lead to ingestion failures. Once the so the process flow is, once the data ingestion completes, the middle manager creates the segments with the ingested data and pushes the segments to deep storage. So once the segments are in the deep storage, the coordinator is responsible for loading the segment onto the historical nodes. If for any reason the coordinator goes out of sync, then the segment doesn't get published onto the historicals, and the whole ingestion process fails. So in this case, restarting coordinator is a quick fix. Sometimes mass cache size gets filled up on historicals that would stop historicals from loading segments, and this would cause ingestions fail. In this case, increasing a max cache size would help, and also taking a precautionary step of like having enough max cache size before ingesting any huge data, large data. Next thing is network connectivity issues that we often see in support tickets with respect to ingestion. The network connectivity issues between nodes or ingestion source and the in-play cluster can cause ingestions to fail. For random connection blips, which can span for like sub-seconds, ingestion retries can help. For longer latency, we need to dig deeper for prolonged latency and identify the node that has the network issues. Faulty channel resource pool is a notable exception related to the network connectivity. We saw a lot of them, and there's also a good KB on that if you want to look at it. A quick Google should give you that. There are a few more reasons of ingestion failure. We will see that in the next slide. As I mentioned, this is going to be a big one, so I'll try to finish fast for the time we have left. Okay. So next thing is too few partitions or too many partitions. Both are problematic. Having too few partitions can make the ingestion slow, meaning there will be less parallelism in processing. The other extreme is the large number of partitions and the lack of data. For example, we have seen when an empty event hub is introduced with a large number of partitions, then the ingestion fails. So we recommend having data in the partitions first, and starting with only a few partitions and increasing them as needed and when the data volume grows. Hadoop ingestion failures. We often see Hadoop ingestion failing due to improper classes, missing jars, version mismatch. The root cause of these issues could be easily found at the task logs, and then we can take necessary actions and ensure we have suitable jars and classes are used. And the other thing is any changes to Kafka topics or data sources can cause the ingestions to fail. For example, when a topic or data source is deleted while Druid is sampling the Kafka data, it may cause the ongoing ingestion to fail. This happens because Druid kept trying to work with the data that doesn't exist anymore. In this scenario, restarting OLAs resolves the issue many a times. Other than this, wrong data type or invalid timestamp spec or invalid source path in the ingestion spec and missing Druid extension can cause ingestions to fail. Proper validation of ingestion spec extension and input data is required before proceeding with the data ingestion. The last one on the ingestion failure is bad data or unparsable exception. We have a few configs that controls the parse exception. For example, max parse exception and log exception. These properties determine what happens with the messages the parser successfully parses and finds to be invalid. For example, if the number of parse exception exceeds the value that we have set it up in the max parse exception, makes the ingestions to fail. To mitigate this, we can try setting the max total rows config value to something less than max parse exception. We have also seen unable to parse the row error in ingestions where the parsing itself fails, so it cannot parse for some reason. So we usually saw this when an ingestion spec is using parser JSON, which is an older method. The new method input format is a new way to specify the data format for your for your input data, which was introduced in the Druid. Latest versions of Druid, I think 0.17. And unfortunately, the input format doesn't support all the data formats or ingestion methods yet. For Hadoop-based ingestion, we still need to stick with parser spec. Now we address most common causes of ingestion failures. Let's talk about ingestion slowness next. That's one other major topic. So I promise this is going to be a shorter one compared to ingestion failure. So sorry, I'm going a little fast because we have less time. So please post your questions if you have any. Less task counts. That's one of the major issues with ingestion lags. Sometimes task counts makes Druid to consume data slowly and is unable to keep up with the stream. We had a ticket where customer had like 60 partitions per task, so that's ambitious. So increasing the task count would result in the greater throughput. Task counts needs to be set in such a way to make sure that Druid is consuming the data quickly and do not fall behind the stream. We recommend a 1:x ratio of tasks to shards and partitions, where x is a whole number. Like example, you can set 1:3 or 1:4, where one task for 3 or 4 partitions, something like that, based on the cluster size and on the resources available. Other thing is, if there are not enough worker slots on the middle manager, the ingestion process will slow down and the lag increases. In such cases, scaling up the number of middle managers help. A large supervisor could also make the other supervisor wait for a long time. Based on the criticality, we can either suspend the problematic supervisor or have it run on the non-busy hours so that it would help the pending task complete and the lag reduces. Sometimes customers would have set up a traffic shaper. We have seen this with one of our customer. So it took us a little longer time to figure out. Sometimes a customer would have set up a traffic shaper between imply cluster and streaming applications like or streaming or Hadoop applications. The bandwidth setup on the traffic shaper controls the data flow to the Druid cluster. Having a lower bandwidth would slow down the ingestion process. Increasing the bandwidth help reduce the lag. So that's one thing, and we have seen quite a few times. I think Ben has covered this in his unresponsive endpoint topic about the metadata cleanup. So we have seen quite a few times that wrong entries of indexes and our customer would have done some manual deletes on Druid metadata tables, like Druid segments or Druid pending segments. This could slow down the overall performance of the cluster, not just the ingestion. So optimizing these tables have resolved the issues. We have introduced a feature called feature automated cleanup that Ben has covered already. So in the recent versions of Imply. So if you have a higher high data source churn rate, meaning you frequently create and delete data sources, so there will be entities left on the metadata that would slow down the overall performance. So to maintain that, you can configure Apache Druid to automatically remove the records associated with the deleted entities from the metadata store. So that's all about the ingestion issues. Over to Ben for the next interesting topic on Druid SQL, and that's Ben's favorite too. Over to you, Ben.
Thank you. My favorite subject is SQL and Druid SQL. And I just want to add, when in the last slide, when we talked about optimizing the tables, literally we mean like optimize, like we've seen cases where metadata is in a MySQL database and we ran optimized table Druid segments, optimized table Druid pending segments, and performance improved. It's rare, but it happens. But on to Druid SQL. The main anti-pattern that I want to talk about is thinking that it's exactly like other SQLs. SQL is great. It's an addition that for a while now has been built on top of the native Druid query functionality. It can be more economical, more understandable, easier to write. A lot of us already have knowledge of SQL and can think well on that, as opposed to the JSON queries can be hard to kind of think about. But at the same time, it's not exactly what you're used to if you're coming from an SQL world. Druid SQL doesn't support all of ANSI SQL, but it's not a subset because we also have additional functionality that is Druid specific. So if it's a Venn diagram, it's not a subset, it's not a superset. It's important to know the differences. I think that Gian may have mentioned that in the fireside chat or his keynote. FJ also mentioned that we wouldn't want to just take a data warehouse model, for example, and expect that to work in Druid. You want to take time to understand Druid SQL and the Druid data model. Gian recommended that if you're starting out, you might think of starting with one big denormalized table. Maybe you load it directly from Kafka and go from there. As you get deeper, Cheddar recommended in the fireside chat, understanding how data is sorted and partitioned into segments in Druid. So it's different than your regular SQL, but it's got enough of it that you can really kind of get running with it, and it's very helpful. For me, it's faster to work with than native JSON queries. And in some cases, it can do things that you can't do in native JSON queries because it can use multiple native queries to do one SQL query. So now to talk about some specific commonly seen examples of Druid SQL that can give rise to questions or issues or problems. If we can go to the next slide.
Yeah.
So one thing that surprises people who are new to Druid, if you already know this, and I apologize if you're new, it might be a surprise to you. A lot of results to queries in Druid are by default are approximate results. If you're counting how many users came to this site in this day, you might just want to know it's about 16 million and not care about 382,761. So Druid SQL can be very fast, or native queries as well, and but by default, they are approximations. I'm trying to think of how much detail to go into, but yeah, if an SQL query uses a Druid top N under the hood, it's going to give you approximate results. Count distinct gives you approximate results by default. You can avoid this in general by setting some context settings in the query, or you can set it cluster-wide, but probably better to do it in a query. There are some settings: use approximate top N and use approximate count distinct. You can set those to false. The queries will be slower, but you will get exact results, except in some cases you may not be able to run your query. Druid might say, I can't do it. And then you have to take approximate results. And I'm trying to think ahead, but one thing that if you do want approximate and fast results to look into is sketches. Yesterday, Reddit and Y Labs talked about the use of data sketches, and they can give you even faster approximate results with bounded error that are very useful. And there are SQL extensions to work with sketches. One limitation, as an example of SQL limitations in Druid, if you're doing a count distinct, you can't do it for multiple fields in one query. You can do a count distinct on one field in one query. Maybe in the future that will change, but it's an example of you should get to know Druid SQL and what it can do and can't do and how it works. Now, I'd like to give some examples of particular SQL queries that can act differently in Druid than you might be used to, and talk about some of the things to be aware of there. If we can go to the next slide. So particular ones that we run into issues with are, as we see here, group bys, lots of joins, which people might be used to from the SQL world, but probably don't work as well in Druid and not what Druid was designed for, or very long in lists where my value is in, and then we've seen hundreds or even thousands of things in a list. The reasons these can cause issues: group by can use a lot of memory in your heap. A lot of times people will start using group bys and you'll get an error message saying, couldn't do it. You might want to spill to disk or set max merge dictionary size. Our recommendation, if you're going to do that, would be start with max on disk storage. That just means you can spill intermediate results to disk. You don't have to store it all in memory. If you have a big group by, that can make a lot of sense. The thing to be aware of is that it's per query. So if you're running a lot of group bys concurrently, make sure you have enough disk space for your setting. The reason we recommend starting with that is that max merging dictionary size affects your heap usage, and it may have other performance implications. It's less bang for the buck, probably. It's harder to tune. It can cause problems in other areas more easily. So if you're doing a lot of group bys and run into these issues, you might look at max on disk storage to allow spill to disk for intermediate results like you would with Spark or other systems. Joins can cause issues because first, if you're using them, read the doc pages on joins. There are a number of kind of considerations and limitations, but one thing that is a big one is that if you have two sides of the join, the right side of the join gets materialized in the heap before the query proceeds. So obviously, if the right side has a big result set, this is going to cause issues. Or if you have multi-joins, this can cause issues. So the thing to do is, if you're having problems with the join query, one of the first things to do is look at, can you return fewer columns on the right side? Can you, narrow that side down? Can you return fewer rows? Can you do things to tune it in that way? And another avenue is, in some cases, is to use lookup tables, which we'll talk about in another slide. Long in lists are kind of an interesting area because, again, that might be common in most SQL worlds, but they can take a really long time, especially in Druid SQL. And a lot of that is because of what's called the planning stage, where the SQL gets converted to native Druid queries. And we use calcite under the hood, but it tries all different combinations before it picks a Druid native query. And I don't know, it's doing some kind of combinatorial combination of all the things in the end list maybe, but it can take minutes just for the planning stage if you have thousands of entries in there. So avoid them. One thing that one customer found was, that's kind of an interesting workaround or approach, is there's a function called MV overlap, which is used for multi-value dimensions. It can be used to get the same results as a long in list. If anyone has questions about that, feel free to ping me or ask in the Q&A. It plans more quickly is the reason. Another customer actually would write a query with a couple things in the list and then get a plan, intercept it, and in their code, intercept the native query and put in all the values they really wanted and run the native query, which is a little bit more work. But be aware of long in lists. Group bys and joins have their own caveats. And these are examples of special considerations to have in mind when you're using Druid SQL. You can't just kind of run with the SQL that you're used to and expect it to give you sub-second response in a Druid system. I mentioned the multi-value dimensions, so I'd like to talk a little bit more about that. In Druid, as you may know, we have fewer data types than in some databases right now. But one thing that we have is multi-value dimensions, which can be used for nested data or to store a lot of values in one column. They can be ingested as sets or sorted lists, whether you want it to have allowed duplicates or not. But they behave sometimes in unexpected ways. So if you use them, they can be very useful. But again, make sure you read the documentation carefully. If you Google Druid multi-value dimension, a doc page will come up in the results, and it has details about how they're handled and examples for their usage. For one thing, if you do a group by on a multi-value dimension, it unfolds or explodes what's in a matching multi-value dimension entry and gives you results for everything that's in that list. So you might expect to see them only for the ones that you're filtering on, but you'll get the rest that are in that particular row and column. And same with filtering on it. If you have something that has A, B, C in there and you say filter where this multi-value dimension equals A, it's going to find that row, but then it's going to give you results for B and C too. It matches the multi-value dimension, not the individual entry. So play with it, understand it, and they're very powerful, but it's part of the entry pattern of don't just kind of jump at things like they're going to work as you might expect at first blush. Make sure you understand the details. Another area where this comes up a lot is the next area is null handling in Druid. Nulls are handled differently in Druid than you may be used to. By default, nulls will just get stored as a 0 for a numeric field and as an empty string for a string field. So we don't have a special null value. You can change this by setting a setting use default value for null. You set it to false, and then you get a more traditional or standard SQL-like treatment of nulls. But again, kind of work with it and test it out. One common issue or recurring issue that we've seen, and this is regardless of use default value for null, when you say you ingest a lot of data and one column is empty for all of the rows, that column will not get stored in the segments, and it may not show up. So if you query it, it might say this column doesn't exist at all if there's no data in any row for that column. If you have real-time ingestion, while you're ingesting, the column will show up because it sees your spec for ingesting. As soon as you stop ingesting, or at a little window where you're publishing segments but haven't started a new task, and you query that column, if there's no data in that column, you'll get the error saying this column doesn't exist. So this is definitely different than traditional databases that you might be used to, and something to watch out for. I also, on a recent ticket, found that we have a not a number value that can be ingested into double fields, or as the result of some functions that give double outputs. Something that is a big difference with traditional SQL is that you can't filter on every type of data type. You can filter on the simple ones like numeric and string. If you try to filter on sketches or some other kinds of columns where it equals this, it's not supported yet. And so in particular, for kind of related reasons, if you have not a number of values in some rows, you can't say where. We don't have an is NaN function. You can't say, give me the rows where this is not a number. So it's, again, an example of there are edge cases and things to work on and understand and be aware of. So again, sorry, I'm looking at the notes. I have some more about sketches and filters, but I think I've said enough for the time. The summary is, know your SQL, test, and be aware that it's super powerful. It's really useful. I love it. There are limitations you might not expect if you're coming from a different SQL world. So the documentation is very helpful. If you run into any weird behavior, if you have support with us, open a ticket. If you don't, druidforum.org, ASF Slack, the mailing list, all are good places to ask. So we're improving it as we go. We're going to even build on the SQL functionality. If you saw the yesterday's presentations, using them for ingesting data, for creating data sources. But again, know your SQL and do testing. And if you have questions, please ask. And the next common area that we have for issues, though, that we should get to is on segment sizing and compaction, which is a very common cause of issues.
Thanks, Ben. All right. Segment sizing and compaction.
So,
This is going
Bala,
to be...
Bala, just before you get started, just to know, the end of the session was at 11:40, so maybe wrap this section up quickly so that we'll have time for a little bit of questions, okay? Thank you so much.
Sure, thanks. Appreciate it.
I thought it was 11:50. Sorry about that.
Oh, no worries. So let me run through it quickly. So we'll talk about sizing recommendation for segments based on the type of ingestions. A little bit about compaction and common reason for auto compaction failure. Okay, first one, the lot of segments and its impact on performance. Too many small segments affects performance. It causes the metadata overhead to have too many entries and frequent write operations. It also causes overhead for queries where more files needs to be open and more segments to be scanned. And it would also cause overhead on operating system if files get into thousands. Too many open file issues. The approaches to managing segment sizes and numbers depend on whether the ingestion is batch or real time. So we will see the recommendations for batch ingestions first. So rows per segments are more significant than the sizes of segments. A lot of rows have more overhead to process. Use target rows per segment or numshots. The rule of thumb is shooting for 500 MB to 1 gig of size. The target number of rows to include in a partition should be the number that targets segments between 500 MB and 1 gig. So the number of rows defaults to the ideal number that we recommend is 5 million rows. For numshat, numshat is basically specifying the number of partitions directly instead of large partition size, instead of the target partition size, sorry. Again, the rule of thumb is 300 MB to 700 MB or 500 to 1 gig of size. Okay, moving on to real-time ingestions. So we tune the jobs to control heap memory usage by periodically persisting in-memory real-time segments into the published segments. It is usually set to for 5 minutes. So this would lead to having too many small segments, and it's necessary to compact those segments to avoid performance issues or degradation. Auto compaction is beneficial here. With auto compaction turned on, coordinator periodically submits a compaction task to reindex the small segments. To enable auto compaction, you need to configure it on the each data source via coordinator's dynamic configuration. Certain configs help to parallelize compaction, like max number concurrent subtask and compaction task slot ratios. So I'll talk a little bit about auto compaction shortly after a quick slide on too large of a segment size. Okay, we also have now what we should do if the segment size are larger. Hashed or single dimension partitioning can sometimes lead to bigger huge segments regardless of settings. Hash partition is basically segments are partitioned based on the hash of all dimension, including timestamps. Usually this leads to segments with even a size of sizes, but with a bigger footprint. The reason is because this method does not do anything special to promote data locality, so which is necessary for compression. Single dimension is again single dimension segments are the segments are partitioned based on the ranges of single dimension. This usually means that your data is skewed. A single hash value or dimension value will not span multiple segments within a segment granularity of a particular interval. So if this happens, review a hash or the dimension choice, or consider using dynamic partitions. So dynamic partition is based on the number of rows or segment size. Next, we will talk about auto compaction failures and causes. So we often get support tickets saying like we enabled auto compaction, but it's not kicking off. So why? We need to pay attention to few configs while setting up auto compaction for a data source. One of the most frequent issues is having too small of a value of input segment size bytes. The total size of the segments for a particular interval should be less than this configured value. Otherwise, the auto compaction fails. Task priority. So Druid indexing tasks use logs, and each log is acquired for the combination of data source and then interval. Once a task acquires a log, it can write data to that data source and the interval acquired for the unless the log is released or preempted. Each task has a priority. For example, Kafka has higher priority. Streaming ingestions have higher priority, like 75. Higher the number, higher the priority. Batch ingestions or Hadoop ingestions have a little lower priority than streaming, which is 50. And for compaction, is always set to default low priority, 25. So when you have like ingestions, task, real time or batch ingestion lined up, the auto compaction won't kick in if doesn't have if the priority is set to default. So that's one of the reasons. And compaction gets its slots based on the compaction slots ratio, task slots ratio, and maximum compaction task slots. So these are determined at the global level. If the compaction tasks are already running with a 100% limit that we set for the compaction task slot ratio, then the auto compaction will not kick in until it has enough slot within the allowed limit. And the other thing is max number of segments to compact. The maximum number of segments to compact together per compaction task. Since the time chunk must be processed entirely, the compaction will not run for the time chunk if a time chunk has a total number of segments greater than this parameter. The default is 150. And skip offset from latest. The offset for searching segments to be compact. I strongly recommend setting this for real-time data source, because you don't want your like real-time data to be compacted when it is like ingesting. If we set a skip offset latest to 8 hours or like 2 days, then the compaction won't run for latest 2 days of data, and it only triggers for the previous time intervals. So these are the most common reasons for auto compaction failure. I'll let Ben to quickly cover the performance part. Hey, Ben.
The Q&A slide, I think we have like 2 minutes and we can't do the other sections today.
Yeah, we can. First of all, thank you both for this amazing information and for all of the work you do to keep Imply customers running, and also people in the Druid community running that aren't even Imply customers. It's amazing work and everybody appreciates it. For the Q&A, I wanted to mention that Kailash was talking about upgrading from a older version, and just the fact that you had mentioned that use the forum as a resource, and also the Slack channel. I think that's good information for everybody that that's out there. In the Q&A, there's only one question at the moment. If other folks do have questions, we can you can add them in the Q&A. But Igor was asking about the garbage collection types and what types are used, and if you tried Z garbage collection from the JDK 11.
That's a great question. I don't think that we've done a lot of testing with it. I wish that we had. It's still a pretty lean team. So as you see, if you look in our documentation installation types, it'll say version 8 of Java. But we have done some testing with later versions, I think maybe even 11. And we don't, as far as I know, I haven't heard of problems with it. It's just that it hasn't run through our entire test suite, and we don't have things set up to kind of certify on the more recent versions. I would love to hear about, or maybe even do any testing with, seeing another garbage collection options, but I'm not aware of any results with timings or kind of certifying on those. So I don't know. Hopefully that answers the question. I mean, I know that's something that would be great and that I've kind of looked for myself, but maybe in the future.
Thank you so much. Yeah, I know that I'm pretty sure Java 11 is on the map, so we should see that coming. So I think that we're out of time and we're out of questions. My heart is broken that we don't get to see the rest of this information, because I know that it is so awesome. Next year, you guys will have to sign up for 2 sessions, for 2 talks, maybe split it into 2 days. But
Day
this
1 and
was,
day 2.
Yeah, absolutely wonderful information. And,
Thank you.
I personally appreciate all the work that you do, and I know that everyone does it. Let's see. Actually, there's something else in the Q&A. Kyle, that's one last thing. Is the no brokers available exception a catch-all? I'm getting...
It sounds like a catch-all. I don't remember seeing that particular exception. I mean, that sounds pretty generic. I don't know if you've seen that one in particular, Bob. It sounds to me like we had a section on lookups and there's a cache not initialized error, and it just means something went wrong. It sounds like no brokers available could mean a lot of things. Network, the brokers are down, the services are unresponsive.
I have seen this particular thing somewhere recently when I was looking for it. When I was researching for this presentation. I can't recollect. Maybe I'll search and then probably respond to you. Who asked that question? Maybe I can reach out to them later.
That was Kailash.
Okay, cool.
So I'm going to go ahead and wrap up the interactive QA at this time, but the session chat is still open as long as anybody's in this room. Thank you both for such a wonderful presentation, and I will see you back on the lines.
Thank you.